Alright, so I'm going to quickly walk you through how to make a hinge for your sunglasses. So once you've got your sunglasses designed, you should have separate bodies for your arms and the frame. I'm a little laggy here. So that we can actually create two separate parts that will hinge and fit together nicely. So first things first, for creating your hinge is we're going to need a plane that we can draw out the basis of our hinge on. So I'm going to do an offset plane from the bottom plane here. And I'm going to look at this dead on from the right, and I want to get this guy so that it's sitting right up, about halfway up where our hinge will be, in between the frame and the arm. So this looks about perfect for me. I'm going to hit enter. And so now I have a new plane that I can create a sketch on. So I'm going to go ahead and do that. I'm going to create a sketch on that plane, and I'm going to drop down create and use the intersect tool so that I can see exactly where everything's at. So I'm going to click, I'm going to select bodies, I'm going to choose this, and the arms. Your glasses should be symmetrical, and so I'm just going to do one and mirror it over. If your glasses aren't symmetrical for whatever reason, you may need to do this twice. But I'm going to go ahead and I'm going to turn off visibility of these guys. And so now I have the geometry of what this connection looks like between the frame and the arm here. So I'm going to go ahead, I'm just going to delete some of the stuff that I don't need, just keep things simple. And like I said, in my case, I'm just going to mirror it over, so I'm going to delete that as well. And I'm going to select all of this, I'm going to fix it in place, and then I'm going to select it all, and I am going to use the construction command so that these don't interact and mess up anything that I'm sketching. It really, for some reason, doesn't seem like toggling points, visibility on and off, works for locked construction lines, which is unfortunate, but we're just going to keep rolling regardless. Okay, for starters, we're just going to go ahead and create a sketch, or a couple line segments, I should say. And let's do them, I'm just going to start with a line segment here. I'm going to dimension this, let's do 0.25 away from the inside of the arm. This is in millimeters, by the way, because this is the part that's going to attach to the front of the frame, and we need a little bit of space between them. It can't be right up against it, otherwise it won't have enough tolerance to work. So big key factor for building these hinges is using the right tolerances. So you'll need to use the tolerances that I give you. Even if you switch up the shape of the design at all, it has to be these tolerances, otherwise it just straight up won't work. So I'm going to go ahead, I'm going to create another line segment over here coming out, and then I'm just going to create a line between the two and trim off the excess using the trim tool. And this is going to need to be roughly squarish, maybe just a little bit longer from this point to this point than it is wide. So I'm going to dimension these to be, let's do 2.7, and I'm going to dimension this to be maybe 3.2, something like that. And then I'm going to round over both corners here, and we want essentially a full round fillet. So I'm just going to drag this up until I get a full round. In this case, what I can also do is I can, because this is 2.7 millimeters wide, I can do 2.7 divided by 2. So that slash is your divided by sign. And it doesn't seem to Seems like it's breaking. Let me try it again. Select both of these. So it just doesn't like me fully removing the straight line segment here. So I'm just going to redimension this to be 1.9. Wow, it is being really weird right now. Maybe rather than do it this way, I'm going to delete that. I'm going to create a circle, and I'm going to make these points connected by using the coincident tool, which is basically a connecting tool. And then I'm going to make sure that these are tangent to the circle. So I'm going to use my tangent tool, click there and there, and click on here and then there. And then now I will mention this to be, I guess, 2.9. Okay, and then I'll do one more line segment coming across the back here. Alright, so our center kind of axle, I guess, for the hinge, we're going to want to be 2.5 millimeters in diameter, which, okay, it is going to be a very tight fit on this pair of glasses. I may need to make this a little bit wider here, so let's go ahead and do that. I'm going to delete this and that. And then I'm going to make my main circle a decent bit bigger here. And I'm just going to connect it in here, kind of arbitrarily for now. And just to beef this up a little more, it's just concerningly small. Okay, so 2.5. Is the size there for your axle, and then you'll need a 3 millimeter hole that it passes through. So I'm going to do 3 there. Seems like this is still not dimensioned properly. Let's dimension this point to that point to be 2. Okay. So this is my piece here. It's a little messy right now. You're just going to have to bear with me. I'm going to go ahead and I'm going to select all of these guys and convert them back to standard line segments so that I get a solid body here. Okay, I'm going to go ahead and finish my sketch. Yeah, I'm going to finish my sketch here. I'm going to turn visibility of these back on. And I'm going to extrude this guy to be total distance of, let's go for like 2.5 millimeters. So this is going to be like the central axis for our hinge here. And then let's go ahead. I'm going to turn visibility of that last sketch back on. And we're going to extrude everything else. That's everything here. And we're going to use we're going to change this from profile plane to offset. And then our offset is going to be this extrusion basically divided by 2. So in this case, because it was 2.5, and I didn't mean to click that, that's why it's cutting. I need to change my offset to 1.25, so that's half. And then I'm going to change my extrusion distance to 1.5. maybe even a little more. If you can squeeze in more, the more the better. This is a really small part, and so I'm kind of concerned about the stiffness and it breaking. And I'm realizing that my frame tapers back here a little bit, and so this is not currently connected. So I'm actually going to go back in and edit that first sketch, and I'm just going to turn visibility of that off. And I'm going to just come in here and add just a decent bit extra, just to be on the safe side. There. And then I'm going to edit this last extrusion to include that. And click OK. And that's going to join it all together. So I'm going to turn visibility of this sketch off. Okay. So we've got the top portion of the hinge done. I'm just going to mirror this over to the other side. So the reason that I did this first extrusion as a symmetric extrusion, you're going to need to make sure that you did. And by the way, I used whole length as opposed to half length. I'm sorry if I didn't mention that initially. Is because now I can just mirror this over the sketch plane. So if I drop down Create and go Mirror, I can change this from Bodies to Features so that I can select this extrusion. And I'm going to select my mirror plane as my plane here. And then click OK. And so now I have, it's cutting in here a little bit. Sorry, this is a really complex classes frame shape. Yours will probably be a little simpler, but bear with me here. I'm just going to go ahead and use this part. You shouldn't need to follow. I'm going to go ahead and use that to cut the portion of this out. So what I just did there was kind of take this chunk off. Again, you don't need to follow along here. This shouldn't be necessary on your model, but it is here, unfortunately. Okay. So now I've got the hinge that is attached to the frame here, and it looks like actually my pivot point is not connected to the rest of this, so I'm just going to join them like so. So now I have all of this as being a single piece here. So this is all, this hinge is part of this assembly. And so now I'm going to go back into that original sketch that I had created. And now I can just connect this guy over to this side portion here. So I'm just realizing actually that when I did this extrusion, I think that, okay, no, this is good. Okay, perfect, never mind. I was worried that I had extruded the this ring as well as this ring, but this is supposed to be the hole and this is the shaft, and I had just extruded just the shaft. So this next portion is going to be using this hole here, and I'm just going to offset inward from this. I press O for offset, and offset this -0.1, just to give us a little bit of extra clearance here. And then I'm going to take a line from here directly over to the side. And in fact, I might even go for something with a little bit of angle to it. Just for a little extra stiffness, the more the better. And I'm just going to make these tangent, so I'm going to select both of them and click on tangent. And then now my tangent tool's active, so I can also just click on a circle and a line, and it's going to make them tangent to each other. And I'm just going to connect these two, like so. Alright, so that's going to give me kind of the basis for the hinge portion that goes on the arm. So I'm going to finish the sketch. I'm I'm going to turn visibility of that sketch back on. And we're going to extrude this, as well as these parts here. And one easy way to figure out how far to extrude is if you just click on this face, it's going to figure out exactly how far that is. So 1.25, but we want a 1/10 of a millimeter clearance, so we're going to do 1.15. I'm going to change my extrusion direction from one side to symmetric, and I'm leaving it at the half length because I want 1/10 of a millimeter here and 1/10 of a millimeter at the top. And then I'm going to change my operation from cut to join so that it'll glue itself into this arm here. And then I'm going to click OK and turn visibility of that sketch off. And so now I have a hinge part here. And I'm going to use a section analysis to show you exactly what it is that I've done. So if I drag the slicing plane up a little higher, I have kind of the basis of the hinge here, and then now you can see that I have the hinge attaching to the arm like this, and then I have a little bit of a gap between here. So this was 1/4 of a millimeter on either side, so a total difference in diameter of 1/2 of a millimeter, 2.5 for the shaft, and 3 for this outer ring. And then again, I have a 0.1 millimeter difference between this face and this face. So you can always double check that by using the measure tool. Click on one face, click on another, and you should see a distance of 0.1 millimeters. And then also, just to triple, quadruple check this guy, I can click on measure and click on this face and then that one. And then the minimum distance between the two is 1/4 of a millimeter. So that's a distance on one side. And so the total difference in diameter from the 2.5 to the 3.5 to the 3, is 1/2 a millimeter. So those are super crucial for this hinge to function correctly. The other thing you want to make sure is that if we move this guy, so I'm going to use the move/copy tool. I'm going to select my arm, and then I have my rotate selected here, and I select my axis, and I just click on this ring here. If I rotate this, nowhere along this does anything intersect one another. Well, I guess I'm glad I checked, because it looks like down here on the bottom, because this is slanted inward, I am getting a little bit of interference. So in order to fix that, what I'm going to do, I'm going to hit cancel here. I'm going to go ahead, I'm going to hide this arm, and then I'm going to use the chamfer. Click on both of these profiles here. I'm just going to go all the way just for the sake of continuity. And I'm going to change this from equal distance to 2 distance so that I can bring this up higher than I am bringing this back, because it really doesn't need to go that far. So now I have just a slight draft angle all around this, and I may go a little bit more. Click OK. Alright, and then so now if I move this guy, rotate it around this axis, I still have space between them. That's what I'm looking for. So it's a tight fit, but now I have space. And then I'm just going to go ahead, I'm going to keep walking up the section analysis here. And now this guy joins back in on top, again with a little bit of a gap here. And everything looks pretty good. So now the kind of annoying part in my case, because I've made so many modifications to the frame, is mirroring this over. But to keep it simple, I might just split this body in half. And then I'm just going to mirror it back over to this side along with the arm. So I'm just going to use my mirror tool and click on this. Oops, not features. Bodies. This and that. Looks like it's only going to let me select one at a time. Right there. And then I'm keeping my operation at join in this case because I want this all to be one continuous frame here. And then I'm going to mirror over this over this plane, like so. And I'm going to change this to new body just in case so it doesn't stick everything together. So now I have my sunglasses. Now, one more thing for printing these on the 3D printers we have. If you can fold your arms in, then we'll be able to fit a lot more sunglasses on each 3D printer. So I'm actually going to edit this feature. I'm going to come in even a little farther. Let's see if that... Okay, good. So that just barely doesn't intersect itself. There's a little gap between those two. And then now I'm just going to go ahead and move this one outwards until it's going to be fun to pick this center as the axis here until it's not intersecting itself. So I'm going to go ahead and rotate this way. Let me check the top view. Okay, so no intersection here. Yeah, this all looks good. So these hinges are going to print in place. We don't actually need to like assemble anything, which is really nice. So yeah, if you're happy with your sunglasses, you've got them folded up to be as compact as possible, just without overlapping itself, obviously, and you're ready to print it. I'm first going to save it. And then for the other printers that we've used, we exported as STLs, but these printers that we're using are more capable, and so they can do colors, and the other thing is they can import multiple bodies and still have them aligned. So if we exported the frame and then the arm and then the lenses each as STLs, when we import them into the slicer software for the Stratasys 3D printers, there won't be any real location data, and so they won't align nicely. Whereas if we export this as an OBJ as opposed to the STL, they'll all come as a complete package. It's super easy for us to 3D print, so you're making our job easy in doing so. So the thing to do right now is first, these printers can do grayscale. So decide what color gray you want. In order to change it, we'll go from design to render. And we're going to click on appearance, and then we are going to, you can use whatever material profile you want. Just understand that if you use a color, it's just going to use the grayscale equivalent. So a super light pink would just be a very light gray, and a dark brown would be a dark gray. Just doesn't have any color capabilities. It can, if you're interested, you can do individual colors on different faces. So if I switch my appearance to faces, and then let's say I wanted to do something, I'm just going to use ABS because it's white. If I wanted to do like the nose piece white for whatever reason, the print will now print this part as white and the rest of this as gray. Important thing to note, this material has a texture embedded in it because it's a powder coat. The printer will not print that texture. So don't be concerned about that. And if you're wanting it to print that texture, I'm sorry, but it's not going to. This is just a texture thing, and this like bump map is not actually in the model itself. And so the other thing too, when you upload this, let us know how dark you want the lenses tinted. Just give us a percent from like 0 to 100. 100 being fully blacked out, 0% being as clear as the printer can do. These won't be fully optically clear, but it gets pretty close, and at least for seeing them sitting on the desk, it looks great. If you wear them, you can't really see through them. It just looks like you have a very, very dirty pair of glasses. So once we've picked our colors here, so I'm going for like a 50%, like a medium gray with a little bit of white on the nose bridge. And then, you know, let's say that I wanted these to be relatively tinted. I would, when I submit them, maybe leave a comment that says, hey, lenses 60% darkness or whatever. We are going to file 3D print. We're going to change this format to OBJ. And actually, sorry, we can't do file 3D print. We have to do file export for exporting multiple bodies. So we're going to do file export, and then please put your name. And then we're going to change step files to OBJ, and then you're going to save it wherever on the computer, and then you'll submit that file in Canvas for us to 3D print for you. So key takeaways here, the things that matter most, and you know, go back and double check. Go ahead and look all around your hinge, make sure that nothing is intersecting itself. Because if it is, when you go to print this, the hinges won't actually fold. And then the other thing is knowing that, hey, you can change colors as like an individual face difference, as opposed to just the you know, frame is only one color. So if you're interested in doing that, like I showed you in the appearances tab, you can select faces instead of bodies, and you can do some cool designs that way. Okay, that's gonna do it for this video, I think.